What is decision analysis? Decision analysis is a form of decision and is a discipline comprising the philosophy, theory, methodology, and professional practice necessary to address important decisions in a formal manner. Decision analysis includes many procedures, methods, and tools for identifying, clearly representing, and formally assessing important aspects of a decision, for prescribing a recommended course, be actions, be applied the maximum expected utility action a well-formed representation of the decision, and for translating the formal representation of a decision in a corresponding recommendation into insight for the decision maker and other stakeholders. Practical representation of decision analysis problems commonly use influence diagrams and decision trees. Such tools are used to represent the alternatives available to the decision maker. The uncertainty they involve an evaluation measure representing how well objects will be achieved in the final outcome. This is the examples. Decision maker attitude to risk is represented by utility functions and their attitude to threat. Of between conflicting objectives can be expressed using multi-attribute. Value function is multi-attribute. Utility functions if there is sync albeit. In some cases, utility functions can be replaced by the probability of achieving or certain aspirations level. Decision analysis advocates choosing that decision whose consequences have the maximum expected utility, or which maximum the probability of achieving the uncertain aspiration level. Such decisions analytic methods are used in the wide variety of fields, including business, planning, marketing, and negotiation, environmental remediation, healthcare research and management, energy exploration, and litigation and dispute resolution.
Decision environment. Decision making is easier the more information is available. There are 3 decision environments. Certainty. It is one in which the decision maker knows with absolute certainty the state of nature that are going to occur, knowing the state of nature that is going to occur. The problem is reduced to evaluating the different outcomes in economic terms and choosing the strategy that leads to the most favorable result. Risk. The risk environment is one in which the decision maker knows which state of nature can occur and the probability that each of them will occur. Under this condition, an applicable decision criterion is the so-called expected monetary value criterion. This criterion consists of calculating the monetary value of each decision alternative and choosing the one that presents a maximum monetary value. Uncertainty. It is the one in which the states of nature are known, but not the probability of each of them. But it can also happen that the possible states of nature are not even known. In this environment, there is little information, and to make the decision will be based on mere intuition.
Mathematical model is one of the types of scientific model that use some type of mathematical formula to express relationships, substantive proposition of facts, variables, parameters, entities, and relationships between variable operations to study the behavior of complex systems in difficult situations to observe interreality. These types of models are mainly used in static areas to represent problems or situations in the real world, or to analyze, explain, or describe phenomena or processes that could occur in practice. Examples of a mathematical model can be the size of a population, the speed at which an object falls, and to know how much demand a product generates.
Linear programming is made up of 3 main elements. The first one is alternative or variables. Winning the problem of situation posed is what is begin analyzing. In addition to begin the first step in developing a model mathematician, since the interpretation of the are well defended. The second one are the objectives. They are the result that is being looking to get. For models of linear programming, these results can be maximized or minimized, the objective function or the goals. The third one are the restrictions. They are the limitations in the problem or situation. This can be explicit, that is to say that they are measured verbatim, or implied, which are inferred from the target you are looking for. Main phases of linear programming. The definition of the trouble. It involves the determination of the three main elements of the linear programming. There are the alternative, objectives, and constraints. The second one is the construction of the model. It is the transformation of what has already been proposed in the definition of the problem to a mathematical model, where the most uses is linear. In case the proposed model is too complex to be solved through linear programming, one can resort to heuristics, which are procedures, intuitive decisions that do not guarantee a solutional optimal. That is from Hillier and Lee Elberman, 2006. Or the situation. The third one are the solution of model. According to Samuel Allion, one of the UK leaders in research operation, optimism is the science of absolute. To satisfy is the art of the feasible, so the solution of the model must be as close to the science of solution, as long as there is coherence with the time taken in the study and the cost of the same. That is, the solution that maximizes the standard objective. The fourth one are the violations of the model. Is this the verification of the effectiveness of the mathematical model, that is, results obtained are consistent with the objective or goal set at the beginning? And one way to check if it's truth, past, or historical data of results. If this did not exist, we could support each other simulators to have greater security in the information obtained. Fifth one and the last is the implementation of the solution. This last stage, as its name says, is the implementation of the results obtained. For these implementations to be successful, the benefits should be shared will be achieved with the solution. Define your plan, commissioning, and training if it's necessary to the areas involved. During this stage, must be closely monitored to the identified and time any deviation in the results proposed by the model to be able to make correction in the model.
To answer an exercise using the graphical method, the exercise says a laboratory has 600 grams of medicine to take big pills and small. The big pills weigh 40 grams and the small weight 30 grams. It needs at least 3 of the big pills and at least needs the double of the small pills than the big pills. Each big pill provides a profit of $2 and the small pill $1. How many could be elaborated to get the maximum gain? Okay, the variables in this problem is x1 number of the big pills and x2 number of small pills. Now you can read again to find the objective function. In this case is maximize fx equals 2x1 plus 1x2. The next step is find the restrictions. Is this restriction 40x1 plus 30x2 less to 600, and due to math operation only put the number where it corresponds, and you only need to make an equation. You divide 600 into 30. The answer of x2 is 20 and the answer of x1 is 15. And you need the restriction to start the equation to get the numbers to put in the graphic. To get the option to get the optimal solution, you can solve one by one variable, first solving the x2 and before the x1 is like the last step. Now after to solve the equation, you need a graph to the results of x1 and x2. This part is called feasible area, and you can find the points in this graphic you can use to find the optimal solution. To find the optimal solution, you must replace numbers of the graph, and the major number is the optimal solution. Due to math operation, you can see the major number is 24, And to find out our correct answer, you can replace the restriction and the answers must be past the limit of the answer. 40 by 6 plus 13 by 12 equals 600 is like the the restriction, and therefore is this problem is correct and must be made 6 big pills and 12 small pills, and the maximum profit is 24. Thanks for watching.